All right, welcome back for part two, and we're going to be looking at what can move across a membrane and get to osmosis and dialysis. So, what are two things that can move across a membrane to change concentration? So think about what concentration is in general, right? It's solute over solution volume. So some amount of solute one way or another, and then the volume of the solution, which is mostly going to be the solvent, which is usually water, right? So if you wanted to change the concentration, you could change this or change this, right? We have kind of like two options. We can change the amount of solute in the numerator, or we can change the solution volume by changing the amount of water in the denominator. So those are exactly the two things we're going to look at and what they're referred to as. So if the solute can move across the membrane to change the concentration, this is called dialysis. If water moves across the membrane to change concentration, this is called osmosis. And we're going to walk through each of these two types and some of the implications, like what happens, how it happens, and why. So let's look at dialysis first. Okay, here's our definition again. Dialysis is the diffusion of solutes across a semi-selectively permeable membrane. Okay, so let's look at situation A, which is kind of like our initial situation. We have a gradient, right? A semi-permeable membrane in the middle. We have high concentration on the left, lower concentration on the right. What's going to happen if solute can move from high to low until they're equal, right? That we're going to have more diffusion will occur from the higher concentration on the left to the lower concentration on the right until the concentrations are the same, which is what we get here in B. And at that point, there's no change in concentration, right? So if this is high and low, then these are equal. And there's no change in concentration, but remember dynamic equilibrium. A guy digging a hole, the guy at the top throws dirt in the hole at the same rate, right? And nothing appears to be happening. The same thing is going on here, right? So you can see here in the arrows, diffusion across the membrane is still occurring, but the point is it's occurring both directions at equal rates. So the diffusion of solute particles across the membrane still occurs, but at equal rates. So equal concentrations. That is dialysis. Okay, the diffusion of solutes across the membrane. Here's an exercise from the textbook. So here was the question. A dialysis membrane separates mixture A from pure water, right here. Mixture A contains urea in blue dots, which is a small neutral molecule, and albumin, the yellow dots, which is a large protein, a colloid. Describe what the two compartments will look like after dialysis. Okay, so the first thing would be to describe it and then draw it. Okay, draw it in. So what will it look like? Well, what will cross and what won't is one way to think of this. So urea, it's a small neutral molecule. It can cross the membrane, right? But albumin, which is a colloid protein, it cannot cross the membrane. So the little blue circles will be evenly distributed in both sides, while the yellow circles will remain on the original side, right, on the left. All right, there's kind of what I just said. And then here's a picture, right? And so the yellow circles, right, we have 1, 2, 3, 4, 5, 6, 7, 8 in mixture A in the beginning, and we still have 8 in the end. Now, for the sake of this picture, they're drawing them, in like exactly the same places. They won't be. They're still randomly moving around, but they're going to stay on that side of the membrane. And then I'm not going to bother counting, but however, we started with a certain amount here, and now half of it is on each side, right? So we have equal concentration of urea on both sides. And this is one way by introducing, something with low concentration, like pure water, and a membrane, we can actually remove something like urea from a solution. Okay, and this will come back up again in the dialysis that you've probably heard of. But let's look at a few more questions first. Here's a practice exercise. So consider two solutions separated by a dialysis membrane. One side contains half normal saline, which is 0.45%, and the other contains normal saline, or physiological saline, or 0.9%. Question A, which solution is hypertonic? Which is hypotonic? In which direction will the sodium and chloride ions diffuse? And how will the concentrations of each solution change after dialysis? So now we actually have the introduction of two new terms, which I will define in a later slide. I think this one got a little bit ahead of us here, but we can do it right here. So these kind of make quite a bit of sense. So hyper always means high or more, or like a large amount, and hypo is always less or little. And so tonicity, or the tonic, has to do with the concentrations, right? So whenever you have a concentration gradient, hypertonic is the higher concentration one, and hypotonic is the lower concentration, or like the more dilute solution, right? And then there's a point at which they're equal, right? When the solutions have stopped, or the dialysis or osmosis have kind of reached the equilibrium point, then they are called isotonic, which is the same concentration. Okay, so those are the first two questions. And then in which direction will the ions diffuse, and how will the concentrations change after dialysis? Okay, so which one is hypertonic? Well, we've already kind of defined that, right? It's the one at the higher concentration, so the 0.9%, or the normal physiological saline. Hypotonic is 0.45%. So question C, in which direction will the sodium and chloride ions diffuse? Well, it always goes from high to low, right? Which can also be now thought of as from hypertonic to hypotonic. So it will diffuse from the normal to the half normal saline. And how will the concentrations of each solution change? Well, the higher solution will decrease, or the hypertonic will decrease in concentration. The hypotonic will increase in concentration until they're the same, till they're isotonic. And in fact, if you have equal volumes of the two solutions, the final concentration will be exactly in the middle between 0.45 and 0.9. Okay, just to keep it reasonable here, let's stop, and in the final part we will talk all about osmosis.